Greetings. This is going to be a brief overview of a bioacoustics effort recently started in the greater Yellowstone called the Cry Wolf Project. It builds upon 29 years of wild wolf research in the greater Yellowstone since their reintroduction in 1995 after being exterminated in the 1920s. A couple of months ago, a few of us were skiing in the backcountry of Yellowstone to put out a non-invasive acoustic recorder at a wolf den site. The females are probably whelped by now, and there might be pups in this actual den. This is a thermally active area and probably keeps the pups a little warmer, and no doubt one of the reasons this pack continually returns to this particular site. I'm going to play a recent audio clip from a female wolf called 907F, one of the longest living and the most prolific female wolves in Yellowstone, who has one functioning eye. And when she made this howl, she was separated from the rest of her pack. An hour earlier, elk had just come running by our recorder, perhaps with wolves chasing them, and this is what the elk sounded like. So humor me and close your eyes. An hour later, she howled like this for over 30 minutes. Okay, open your eyes. This is what she said, at least in spectrogram encoding. Now, the fundamental frequency of an average wolf howl is about 350 hertz, or middle F on your piano keyboard. But the stout 110-pound 907F and her particular idiolect howls at 320 hertz. And we can pick her out in a crowd when you hear her out in the field. If you've never seen a spectrogram before, they're pretty easy to interpret. This is how they work. On the y-axis is frequency or pitch, low frequencies down low and increasingly higher as you move up on the y-axis. The x-axis is simply sound over time, so sound as it plays over time. And then the brightness of the color indicates loudness or amplitude. Darker meaning not much sound at all, and increasing shades of the color indicating a louder sound. And here she is, the matriarch of the Junction Butte pack, the one-eyed wonder, as you can see from this infrared photo. Here's just a few of the project objectives and the science behind it. We're coupling ARU, or Autonomous Recording Unit, devices to get recordings, plus camera traps, plus collar data, plus field observations, plus genetics, and a lot more data, and engage citizens, and Yellowstone has all of those. We're trying to build a better camera and audio trap for scientists and researchers. We believe in haystacks or big data, but we also believe that context is necessary. We build AI classifiers to find those wolf needles in that big data haystack. We're using bioacoustics and seeing if we can use it as a low-cost population and presence modeling tool. We're interested in what's a wolf word, or a phoneme for that matter, and the Holy Grail, finding some combinatorial meaning, or what's called two-slot syntax. We're interested in the evolution of canid language, from wolves to dogs, with humans in between, and of course carnivore conservation, and doing a better job of translating wolfish for people, livestock, and wolves. Here's the study area, both inside the park where they are protected and outside the park in Montana where I live. The polygons represent various pack territories. The push pins are just some of the recorders we have out. We space them to pick up wolf vocalizations, which can travel 6 to 8 kilometers depending upon environmental condition. Here is the Rescue Creek pack, and here is 907F's Junction Butte pack. The lack of rugged, power-efficient, vertically integrated monitoring hardware and software that scales is a serious shortcoming in terrestrial wildlife ecology and management. So we've been building and testing our own integrated devices that record localizable audio 24/7 for up to 6 months on a rechargeable battery. And it can also record video using an AI-based thermal smart trigger that doesn't do things like take photos of grass blowing in the wind. Now, outside the park, we're testing these devices to detect wolves and then play back low frequency howls or even guard dog barks to see what level of wolf deterrence we can achieve in livestock conflict scenarios. In the last 6 months, this is what we've accomplished. And if we raise some matching funds, we're going to continue the research for at least 3 years. Now, down at the bottom is 1,500 hours of actual eyeballs looking at wolves and documenting their behavior in the field, which we then couple with the nearest audio recorder for further analysis. Here's a false color spectrogram of sounds made at one recorder for the full month of last August. Now, each horizontal row is corresponding to a recording of 1 day of sound, with midnight being on the left edge, and there are 31 rows for the month. Now, you can actually see the dawn chorus of birds shift slightly to the right as daylight decreases over that month time frame. And here in the circles, you see just the wolf chorus howls. Now, wolves talk more at night until the breeding season in winter, when they increase their daytime vocalizations, and our AI helps us find these needles in the haystack of the chorus howls. Now, aside from the chorus howls, wolves make over 20 call types, including howls, barks, yelps, whimpers, whines, moans, whoas, and even teeth clacking. Wolves are cooperative breeders. They live in kin-structured social groups with inbreeding avoidance, and they're primarily monogamous. And they are one of a few species who collectively communicate in group vocalizations using role-based linguistic units. And we think they're a great study subject for social animal communication. Inside the park, the #1 mortality of wolves is other wolves. And this is a photo of the Rescue Creek pack on the riverbank, who had trapped a rival member from the Junction Butte pack after it crossed into their territory. And we're interested in wolf communication strategies when other packs are nearby. The #1 cause of death outside of the park is human. It's often a politicized topic and back in the press again if you've been following the Colorado reintroduction, as well as the news covering the Wyoming man last month who ran down a wolf on a snowmobile, which is legal there, then duct taped and took it to the local bar before killing it, and was fined $250 for possession of a live wild animal. Now, do wolves change their vocal strategies when around humans, and how would that influence population estimates based on bioacoustics? Of course, wolves are no spring chickens. They kill too. And in Yellowstone, elk are their primary diet, and those carcasses draw in ravens and grizzly bears and all sorts of interspecies interactions. In particular, ravens have a particular caw call that they use when fresh meat has been found around a kill site. In 1999, Martin Nowak and David Krakauer published a paper in the Proceedings of the National Academy of Sciences titled The Evolution of Language, which outlined the math as to why the combination of smaller sound units are necessary to overcome what's called the linguistic error limit. It's an elegant, convincing work, and it's thankfully short. The opening sentence reads, quote, "Language remains in the minds of many philosophers, linguists, and biologists a quintessentially human trait," end quote. Now, whether or not non-human primates, chickadees, sperm whales, prairie dogs, or wolves leverage linguistic recursion remains to be seen. But we have found wolves use multiple strategies to get around the linguistic error limit, including repetition, sound duration, frequency modulation, gestures, and at least 4 known examples of what is at least compositional meaning. Here are spectrograms of 50 different types of just the wolf howl, arguably one of the most iconic sounds in nature. Now, while some researchers claim there are different semantic functions for a few of these, no one has quantified or proven their existence with, for example, playback experiments, N400 studies, or fMRI. And we're using AI to help us tease apart those possible functional meanings. So to give you a sense of the variation in just the wolf howl, here's one of our recordings of a wolf who did this sequence right before its pack mates responded with a chorus howl. Now you might be asking, are these different words here? Are there any morphemes in here? Small semantic units? How about phrases with dependency pairs, as linguists call them? Or are they simply a wolf's version of synonyms, different sounds saying essentially the same thing, namely a recruitment of one's pack mates? Here's the chorus howl response from its pack mates. Chorus howls are a roughly 2-minute coordinated communication event with a minimum of 3 different call types. I'll play a segment of it for you. Now we're seeing that 3 out of 4 days on average have a chorus howl per recorder. And we have lots of questions. Do particular wolves kick off the chorus howl? Can we count the number of wolves? Or is it computationally unlikely? And do pups learn the probabilities of any of their phonetic repertoire from these social chorus howls? Now to get there first, we're working on a more rigorous definition of a wolf phoneme or syllable, using some of the AI Tweety-BERT work out of Tim Gardner's lab on canaries and Gesper and others' work on adversarial GANs. At birth, wolf pups produce whimpers and whines, and within a month they're already howling. But we found some evidence that wolves appear to practice their speech production basically as they mature. And in the case of this 3D spectrogram playback, it has a juvenile wolf experiencing difficulty with what are called register transitions, or what human singers call passaggio, where you can't go from a low to a higher pitch in one even run. So I'm going to play this, and there are 2 wolves here. One's getting it mostly right, the other's struggling. And here's the one that struggles. It starts the howl, can't get above a certain frequency, but continues the howl. And we're wondering if wolves try to improve their pitch modulation control so as to signal fitness during the more vocally active breeding season. Second, we're working on a more rigorous definition of wolf lexemes or words. And this recent paper from Boros and others using N400 analysis of dogs is a testable approach to finding lexemes. And whether you agree with it or not, it ends with a very bold claim, quote, "This study identifies a dog event-related potential component that reflects semantic expectations, thus providing the first neural evidence for object-word understanding in a non-human species." Now, if you know the lexemes, or the words, you can start looking for phrases, and we've validated at least 4 examples of 2-slot syntax whereby wolves combine 2 separate words into a phrase to produce combinatorial meaning. This one you're going to hear is called a bark howl from a wolf reacting to a different pack that had just tried to kill her. So you hear the bark, and then you hear the howl, and they're combined together. Now, we've heard wolves make this call at variations of it at humans, at capture choppers, and at gunshots on the border of the park. It's interestingly similar to Suzuki and other researchers who studied birds called Japanese tits, where the ABC syllables of the birds equal an alarm and the D syllables equal recruitment. And when they're combined together by the birds, they indicate a call to arms or mob the predator sort of call. It also reminds us of the linguist Progavash, who studied the evolution and still studies the evolution of human language in her work on humans' 2-word swearing combinations. And there's the spectrogram. That vertical bar there is the bark, and then you see the howl, and it's highly modulated at the end. Third, we want to understand what's called the latent space of a wolf's semantic fields. And a latent space is something used in artificial intelligence. We've seen no evidence of any large latent space of wolfish embeddings. If wolves truly only have a small set of linguistic embeddings or words, not to mention an inability to leverage recursion, what are the limitations of that latent space and how does it function neurologically? Here's an initial UMAP, what's called a UMAP 3D plot from just our study of wolf barks. It's very helpful for finding phonetic outliers to look for semantic correlates tied to our field observations. It's been studied in dogs, for example, dachshunds, when they're trained to hunt, they'll have up to 4 different barks that they'll use based on the size of the animal that they're hunting. So one for wild boar, one for fox, one for hares, and one for partridge. Ultimately, we're interested in the question, what do wolves use their language for in context or in situ, whether it be gestural, scent, or vocal? And this video caught our attention. You're going to see a tail-tucked submissive male walk by the screen with a dominant male whimpering as it follows, and an alpha female down there in the bottom left, all during breeding season. So here comes the submissive male in a submissive posture, but it's not whimpering. This dominant wolf in a dominant posture is the one whimpering, and it shouldn't be whimpering at the submissive wolf. Wolf whimpers have this timeless meaning in the sense of begging or longing for something. But in this case, it was communicating two things at the same time. In a context that was obvious to the wolves, we think it was whimpering at the female. And so it's an interesting use of language or communication that you have to understand the context for. Now, you've all likely remembered this album from 1970 by Roger and Katie Payne, and it changed the landscape for whale conservation. But you may not have heard of this one in 1971, a year later, narrated by Robert Redford for Columbia Records. And here is our modern one called Five-Toed Wolf. It's based on sounds of wolves since their reintroduction in 1995 as a reminder to Yellowstone's visitors of what it means to live in a natural predator-prey wild ecosystem. And it uses AI to find those sounds in vast amounts of data. You can go to fivetoedwolf.com, TOED, and listen to the sounds of distant wolves who are helping us understand the wolves of today and those yet not born. So thank you for listening.